I welcome you to this session on geometry. In this session, we will take a look at some basic properties of quadrilaterals. So let us start with general properties of quadrilateral. Say, if we have a quadrilateral ABCD, how do you calculate the formula for area of this quadrilateral? So I do not expect any question on this particular formula or this particular property, but if you are given a general quadrilateral, the area can be calculated by the formula area is equal to half into d1 into d2 into sine theta, where d1 and d2 are diagonals and theta is the angle between the two diagonals. We could have any of these two angles as theta because sine of theta is equal to sine of 180 minus theta, and even if we were to take this angle as theta, it would not affect our answer. So area of a general quadrilateral is given by half d1 d2 into sine theta. Another way to calculate the area of a quadrilateral could be very easy. In fact, converting the quadrilateral into two triangles. So as we have another quadrilateral PQRS, so we draw the diagonal SQ and convert this quadrilateral into two triangles. And if we want to calculate the area of the entire quadrilateral, we can calculate the area of triangle A1 and the area A2 of the other triangle. So we can calculate the area of triangle PSQ as A1 and area of triangle SRQ as A1 and A2 respectively in order to calculate the area of this entire quadrilateral. Let us move on to some other properties of some special quadrilaterals, starting with the parallelogram. So we have a parallelogram ABCD, and in this parallelogram we have two sets of parallel lines, AB parallel to CD and AD parallel to BC. Another property that distinguishes a parallelogram is that the diagonals of a parallelogram bisect each other. So if we have this point O, then BO must be equal to DO and AO must be equal to OC. So this property independently is enough to prove that a particular quadrilateral is a parallelogram. And apart from this, we also know that in case of a parallelogram, any pair of adjacent angle is supplementary. So we have angle A plus angle D, which is equal to angle D plus angle C, which is equal to angle C plus angle B, which is equal to angle B plus angle A, and all of them are equal to 180 degree. Similarly, any two pair of opposite angles are equal. So angle A and angle C should be equal, and angle B and angle D should also be equal. Area of a parallelogram, as you already know, is given by base into height. So where B is equal to base and H is equal to height. Next we have another figure which can be called as a special case of a parallelogram, which is a rhombus. So here we have rhombus ABCD. In case of a rhombus, the first property is all the four sides of this quadrilateral are equal. So if it is given in a quadrilateral that all the four sides are equal, we can easily say that the quadrilateral is a rhombus. Since it's a special case of a parallelogram, all properties that apply for a parallelogram also apply for a rhombus. So in this case, the diagonals AC and the diagonal BC bisect each other at 90 degrees. So you can see there that AO is equal to OC and OD is equal to OB, and the angle made between the two diagonals is 90 degrees. Area of a rhombus is also given by half of D1 D2, where D1 and D2 are diagonals. Another thing that we must know about the diagonals of a rhombus is that diagonals of rhombus also bisect the vertex angle. Next, we move on to properties of rectangle and properties of square. Nothing much here. The only thing that you need to remember is In case of a rectangle, the diagonals are equal, and because they are a special case of parallelograms, they also bisect each other. So we have a rectangle ABCD and square PQRS. In case of a rectangle, you need to remember the following. Number one, diagonals are equal. And number two, diagonals bisect each other. Obviously, because rectangle is a special case of a parallelogram, therefore the diagonals must bisect each other. And both these properties, in fact, are also true for a square. One additional property for a square is diagonals of a square bisect each other at 90 degrees. So apart from the first two properties which apply to both rectangle and square, the third property only applies to a square. So diagonals of a square bisect each other at 90 degrees. Next we have properties of trapezium. ABCD is a trapezium. AB and CD are parallel lines, and AD and BC, which are the legs of this trapezium, are the non-parallel sides of this trapezium. Area of a trapezium is given by half of L1 plus L2 into height, or h, where L1 and L2 are the two parallel sides, and height is the perpendicular drop from either A or B on the line CD, which is equal to h. Next, if we have a trapezium and if we draw diagonals to this trapezium, diagonals represented by AC and BD. Let us say the diagonals intersect at the point O. Then we have AO upon OB is equal to BO upon OD must be equal to AB upon CD. So the ratio in which the diagonals divide each other is the same as the ratio of the parallel sides in a trapezium. Further, in a trapezium, the median is nothing but the line joining the midpoints of the legs. So if we have midpoints of the legs as E and F, so E is the midpoint of AD and F is the midpoint of BC. Then EF is known as the median, and the length of EF is equal to half of AB plus CD. So with this we come to an end of this particular first session on properties of quadrilateral. In case you wish to solve more question, or if you want to watch more videos, you can log on to www.pfindia.com. You can write your queries to us on studentservices@pfindia.com, or if you're watching this video on our website, feel free to use the Ask a Doubt feature. Thank you very much.